You know how magic tricks are really cool until you know how they work? I'm going to kind of do that for you for the internet. Sorry. By the time we're done here, we will examine use cases for public and private IP addresses. And it's kind of the same way for most things. Santa Claus was pretty magical too until you... Oop, hang on. I don't want to go there just in case. Because the fact is, the internet is really just a network. I know, we draw it like a cloud and there's a whole shroud of mystery around it. Like, ooh, what's in the cloud? It must be really complex. And it is, but the only reason it's complex is because it's so big. It's kind of like, well, there's a piece of paper, but if you threw it and there's a billion pieces of paper, you're like, wow, that's complex. How do we make some order of that, right? That's what the internet is. It's just a network of networks. And we have to go back to where it all began, the Arpanet, which was 4 college universities in the United States that said, hey, you know what? Let's do our thing. Let's share some stuff and link up our campuses with this new protocol called IP addressing, right? Now, what IP addresses they actually used is a mystery. I'm sure there's a document somewhere. And I mean, we're talking 1960s, 1970s. There's somebody alive that would know what IP addressing scheme did they use. Did they use the class full? Like, did this university up here just say, we're going to use the 11.0.0. We've got 16 million some addresses that we're using in our campus, and we don't care because, there's no demand for that. There's no shortage of IP addresses. I don't know. I don't know what original IP addresses there were, but the fact is there's a limited number of IP addresses that we are able to use. As a matter of fact, I wonder how many IP addresses there are. Let's ask Google. If we were to go to Google and just type in how many... It's funny. Most common search is how to make French toast. Is it really that hard? How many IP addresses are there? There we go. There are 2 to the power of 32 because there's actually 32 bits in an IP address, IPv4 anyway. There are 4,294,967,926. 296, right? So we've got this big number, but it's actually much less than that theoretical maximum. Because first off, we know that there are 5 classes of addresses, but we can only use 3 in general use. We know that there's certain addresses that are reserved for certain things, or do we? Well, you do now. RFC 1918, probably the most famous RFC in history. I don't know why, it just happens to be, is RFC 1918, which dictates which addresses are actually reserved as private addresses. See, here's the fact. 4 billion addresses, right? I'm curious if I have that many devices in my house. I don't, but that's actually not that many to address a worldwide network. Think of that. Think of that challenge. You have all the devices in the world that are all connected and all have to have unique IP addresses, right? How do you do that if you only have 4 billion of them? And, you just sliced off Class D and Class E. You can't use there. So much less than 4 billion actual usable addresses. So as that network grew from the original Arpanet, there became a need for a divide, meaning we've got all these networks and things that are accessible on the internet. And, there's the original 4 college universities, right? But it didn't take long. Let's add some more universities. And then, there's your first business. And, there's, all these different networks start connecting up. And that's all the internet is. That's your Santa Claus, by the way. I mean, that's your magic trick, by the way, that's not really real, is all of these different networks connect up and become one giant seamless network. But the requirement for that is that they all have unique IP addresses. So maybe this group of people use 200.1.1.0 addresses, and this group of people uses 11.5.1 addresses. And so you've got all of these different addresses that have to be unique, but again, we're at that 4 billion limitation. So someone said, let's cause a divide of public and private IP addresses. The public ones will be the ones that are allowed to route freely on the internet. As in, if you have these addresses, they will work online as long as they are unique. The private IP addresses, well, those will be the ones that people can use inside of their homes, inside of their enterprises. As a matter of fact, let's go on a little field trip. I want to take you to your first RFC. I hope you've never done this before because it's kind of exciting. RFC, request for comments. This is where the standards come from. And notice as soon as I type RFC, it's like, 1918, 1980. It's the most famous RFC. So RFC 1918, we'll just hit the enter key, and there it is. Address allocation for private internets. Private internets? Like we can run our own internet? I guess, kind of. So I'll click on that, and we'll drop down here. It says, here's the introduction. Here's the motivation. Notice words like proliferate. Welcome to RFC. They use words you don't pronounce every day. Proliferation, right? Large groups, TCP/IP technology worldwide, including outside the internet itself. Increasing number of non-connected enterprises need this technology. They need to use IP addresses for their intra-enterprise communication. So notice what it's saying. The businesses, the people who wrote this RFC, which is a really old RFC, by the way, they're like, there's businesses that need to use IP addresses that aren't connected to the internet. So we need to take some addresses and set them aside so people can just use them. But hang on, read more. Let's scroll down a little bit more. And it says, okay, hosts within enterprise can be partitioned into 3 categories. Okay, so you've got hosts, this is devices, right, that don't require access to hosts in other enterprises or the internet at large. So that would be like a lawnmower, right? If a lawnmower had an IP address, I wanted to, I'm hearing there's a lawnmower outside right now. I want to remote control my IP address. It doesn't need to be on the internet. Remote control my lawnmower. I think there's a movie, Lawnmower Man. You don't want to do that. It ends up killing people. But I want to remote control my lawnmower. It doesn't need to access the internet. Doesn't need to access other houses. So that kind of device would need, a private IP address. It says, okay, category 2, hosts that need access to a limited set of outside services, which can be handled by mediating gateways. Aren't you glad you have CBT Nuggets? You don't have to learn networking by reading RFC. What does that mean? It means that you've got a mediator. Think of that. What is a mediator? Somebody who kind of does something for you. Like if you're having marital problems, right? You get a mediator and you talk to the mediator because you can't talk to your spouse. You'll just end up arguing. So she does all these things, and he or she goes over there and it's like, well, you do all that, and they say, well, he does all these things, and so you have this in between, right? So why am I talking about that? Because in the world of networking, you have a mediator too. And by the way, hang on, I'm going to give you a huge term. Network address translation mediator. 1 second. I need to step away from the RFC for just a moment. Right here, I want to put your mind at ease, because in the middle of this line is that mediator. In that, we can use private addresses and introduce a mediator on our router, which the RFC was calling a gateway, right? The gateway mediator. And that mediator can run a feature called network address translation, where it takes these private IP addresses right here and translates them to public. So if you have a device, let's just say that lawnmower, right? That lawnmower is sitting right here, and it's it has a private IP address, but it needs to access the internet to report how many blades of grass it has trimmed down today, right? It needs that limited access. Well, what it can do is it can go through a mediator, that network address translation gateway, and essentially have its IP address replaced with a public IP address. This is the power, by the way, that allowed IPv4 to last as long as it did. Without that technology, without NAT, network address translation, we would have had to move to IPv6 long ago, because we would have ran out of IP addresses, and we couldn't do anything about it. But network address translation allows you to literally share public IP addresses with all your private devices. And the age of this RFC is starting to show, because it's like, that lawnmower or whatever that private device needs to access email or things like net news or FTP. I mean, this is the kind of things we did back in 1996 when this was written. And it says, okay, that a mediating gateway can handle that. Or you have devices that, hang on, it split it. So it says you got devices, and it says, it says, for many hosts in this category, Unrestricted external access may be unnecessary or even undesirable for privacy and security reasons. You don't want your lawnmower to get hacked and then you have, the lawnmower man, a disaster on your hand. Just like hosts within the first category, hang on, read this slowly with me, right? Just like hosts within the first category, such hosts may use an IP address that are unambiguous within an enterprise, but may be ambiguous between enterprises. Hang on. Processing. Unambiguous within an enterprise, but could be ambiguous between enterprises. Think about that. What that means in human speak is maybe my phone has an IP address and it's unique within the enterprise, which could be my house, right? My house is the enterprise. As long as the IP address is unique within my house for that phone, it's fine. It's going to work just fine. But that doesn't mean it has to be unique among other enterprises. Thus the word ambiguous, right? So I might give my phone an IP address that's unique in my house, but my neighbor's house might use that same IP address. But why? Why? Hang on. Because you have a mediating gateway between us. We have a router between our house that's using network address translation to do just that. So I wanted to accomplish just a couple things in this video. I wanted to first off get you familiar with looking at an RFC and interpreting some of that verbiage. I also wanted to give you the idea that you can have IP addresses that you can use inside of your organization, inside of your home, inside of your enterprise, as the RFC was calling it, that are not unique amongst the world. These can be repeated again and again and again. So organization A might use the 10 addresses, and so does organization B. And that's fine, because there is a mediating gateway between these guys. They never see or route to each other directly. Now, let me give you a big what if. What if organization A did a hostile takeover of organization B, bought them out, that's it, you're ours, and then tried to combine the networks together? Well, network engineers would have a lot of work on their hands, because they would have to get rid of all the addresses in here and change them for a different private IP addresses. And the third thing I wanted to accomplish is to make sure you knew what these were. These are the RFC 1918 private addresses. Essentially, anything that starts with the number 10, it's a Class A private range, Class B, Class C private range, right? Anything between 172.16 through 172.31 dot anything, and then Class C, the 192.168, that's probably the most well-known private address in the world. And if we were to scroll down in that RFC right about there, it says, here are the private addresses that we have assigned for people to use. Of course, that middle one is probably the most difficult one to remember. And let me make sure that you're on the same page with what does this mean. It means that if I'm an organization, I can use these IP addresses within my organization without regard. I don't have to worry about registering, hey, I'm going to use these. I can just go and start giving IP addresses out. I can start doing subnetting. I can start assigning different groups in different areas of my organization IP addresses from these ranges. But those ranges will not work on the internet without that mediating gateway. Now, I want to make sure you guys catch this. It's not that they wouldn't. Like it's not like there's something special, like all the routers are like, oh, that's an RFC 1918 address. It's just an IP address, right? Anything from 0000 all the way to 255, anything in that range it's just an IP address. It would technically work. Like if I used an address from this 192.168 in my house, and my house somehow could connect directly to the internet, right? And I'm using 192.168, it would technically work, but every ISP in the world, so your house doesn't have a cloud in the wall, right? Your house has a router in the wall, we'll say. And it connects to Sprint or Cox or Quest, or actually they were acquired, Level 3, or go down the list, all the different carriers that are out there that you connect to. And what the carrier does is right there on their router that connects to you, they put a filter. And that filter actually blocks all RFC 1918 addresses from getting in. So that way, if you messed up on your mediating gateway right here and didn't do NAT and exposed these addresses to the carrier, they would filter them out and block them so you're not able to use them. Okay. Last thing, there was so much stuff. I could just keep talking all day. So let me just stop right here and just say, honorable mention. There's another RFC 3927, also very old, which mentions this range, and it's technically not a private address, but it's same. It falls right into the same category here. These are actually auto-generated addresses. Anything starting with 169.254. So here's the way it works, right? You've got your computers. They're all doing their thing, connected to a network. So here's our. It's a big switch. They're all connected to the switch, right? And usually you'll have a DHCP server that gives them an IP address. When you configure that, it says here's your IP address. Here's your IP address. So these guys are configured to dynamically get their IP address from a DHCP server. But what if you have this guy configured and there is no, this is the DHCP server is down, or somebody forgot to set it up. Well, there's a feature in just about every operating system that says, okay, if I'm configured to get a dynamic address, but that didn't work, then I'm going to automatically generate an address in the 169.254. something range. And the way it works is it says, I'm just going to pick, let's just say, 50.9. And it sends a broadcast out and says, hey, is anybody else using 50.9? And if it doesn't hear back, it goes, okay, then my IP address is 169.250. It just picks one out of the air, right? 99.999% of the time, it won't work. But the intention was, man, if everything's on fire and the DHCP server goes down, at least the computers can kind of communicate to each other and kind of auto-generate address. That was the intention of it. But the fact is, you just end up with computers with random IP addresses that don't really work at all. That's the difference. That's the difference between public and private IP addresses. Private IP addresses are in use in just about every enterprise that you'll run into today. Any business, any home that you'll go into will have private IP addresses running inside of them. Nobody, that's a big word, hardly nobody will ever use public IP addressing to address all their devices, because public IP addresses are costly. They're so limited, and I mean, you're not going to use them to address your devices. You're always going to use private IP addresses. But one thing, I just want to say, how do you get these? How do you get public IP addresses? Well, nowadays you go to a carrier, an internet service provider, and you ask them, hey, I need 1 or 50 or 120 public IP addresses for use. Most people in their homes and small businesses only need a single public IP, and that's included or bundled in whatever they're paying for that internet connection. Anything beyond that, you're typically paying a premium on a monthly basis to use. And that's the story. I hope this has been informative for you, and I'd like to thank you for viewing.